So our next speaker is Dr. Pierre Horholz. Okay, Dr. Horholz comes from the McConnell Brain Image Center, the Montreal Neurological Institute Hospital in Canada. So he's going to introduce us with the brain image data structure and the connectivity project. So let's welcome Dr. Horholz.
Hey everyone, is this working? With me being a bit higher up the mic? Yeah, it's good, thanks. Hello everyone, it's great to see you all. My name is Pierre and I'm very delighted and honored to be here today to present the BIDS connectivity project. Or put differently, developing a practical standard to report brain connectivity experiments. This is an ongoing R1 that was awarded to Franco Pistilli at the University of Austin, Texas, who's sitting up front here. Through the NIH, the Brain Initiative projects. And I would like to thank the organizers for putting together this amazing session and the opportunity to be a part of it. So at first you might think, why BIDS connectivity? And I would respond with, how many people here are working on anything related to brain connectivity? Okay, usually this works better. Maybe it's the wrong session for it, but if you just look at the OHBM program, there's a lot of symposia and presentations and posters centered around connectivity. Now, if we would continue and ask, what specifically do we work on? We would basically get as many different answers as there are people, and that's because there is such a rich, tremendously broad and versatile space of brain connectivity experiments and respective analysis. And what we need to do is to try our best to capture and describe it through overarching components in order to enhance the fairness of these experiments and insights related to brain connectivity, given that it's very prominent in terms of a research field within our entire community, both generally and for specific applications, for example, in clinical populations. If I would now continue with the next question asking, how do you usually describe and store your brain connectivity related data? You would most likely say, whatever fits my needs, whatever the software gives me and so forth, right? Some of you might say, I kind of do it like a BIDS-like structure, like a BIDS thingy, but that's the actual problem. Well, BIDS already has done an amazing and second to none job in covering raw data as well as common derivatives. It's actually missing the capability to sufficiently and efficiently describe these advanced outcomes and all the different data types that we get from brain connectivity experiments and studies. And specifically after an assessment of the research field and all the included data types, what we found is that within this project, what we want to work on is diffusion-weighted imaging models, atlases, relationship matrices, and dimensionality reduction-based networks. Sorry, I went away from the mic. So in order to extend BIDS to cover these aspects as well, we implemented a tripartite approach. First, we started with assembling a team of brain experts related to anything on connectomics, basically, and connectivity research. And this team right now consists of over 20 people, constantly growing. They're from all over the place, across the entire world, across all career stages, working in everything related to brain connectivity. They first came together at a workshop at UT Austin 2 years ago from now, and since then we continued to work asynchronously together online, but also had regular meetings virtually and in person, for example, during all in between OHBMs and brain hacks. And with this stellar team in place, we continued with the second aim, which is developing the actual set of candidate specifications for the description of macroscopic brain connectivity experiments. And this development is following the successful BEP, that stands for BIDS Extension Proposal Approach, and extend the previously funded BIDS Common Derivatives Proposal and Standard. And this approach specifically entails a very precise BEP development workflow over time and different stages of that. Starting with the BEP development in Google Docs, which begins with collaborative drafting within smaller specialized groups, which is consisting of our experts. And then basically those drafts are shared with the entire community, asking for integrating their feedback. We do this for multiple rounds. so that we reach the stage of a final draft that we then submit to part 2, which is integrating this BAP into BIDS via GitHub. And within that, we convert the docs we have to GitHub pull requests, ask for more feedback from the community, continue to refine these proposals until they eventually are deemed appropriate to be merged and thus integrated into BIDS. And just to give you the current state of the proposed extensions, the diffusion-weighted imaging models and atlases are already on GitHub, with relationship matrices and dimensionality reduction-based networks falling during the summer. So at this point, you now might ask, how does this actually help me, right? Like, how do I put my connectivity-related data in BIDS? Let's just have a brief look at some of the BAPs that we've been working on, starting with atlases. As you can see here, we propose to make atlases parts of BIDS derivatives so that they can efficiently be described and shared as part of a derivative pipeline or as a standalone derivatives dataset. Atlases will be organized based on template and reference basis, as well as the modality therein. So in this example you see here, we have two atlases, both are in MNI 152 linear space. We have an anatomical and a functional atlas. In general, these file structures should entail an image file, a TSV, and a JSON file, which we're going to explore next. Starting with the image file, this contains the actual atlas itself, while the TSV file contains information about distinct entities in the atlas. So for example, the indices, the labels, and further information such as what hemisphere they're in, and so forth. And the metadata JSON basically highlights top-level information about the atlas, how it was derived, its license, its space, the species, and so forth. Moving on to relationship matrices. Here we're also proposing to have the data organized based on the derivative pipeline and data modality. So here we go. And following basic BIDS and derivative principles. So no matter the relationship data we're talking about, the respective measures will always be indicated by this new key we're introducing called mesh. The relationship data itself will be provided in a matrix form. Could either be a TSV, a tabular file, or an array format. And depending on the data at hand, those files will either include sparse or dense as part of the file name to indicate what kind of matrix format you are sharing and providing, as well as either have a TSV, H5, or ZAR extension. And basically the idea here is that if you have a classic two-dimensional matrix, this will be a TSV file. If you have a very large and dense matrix and or multiple dimensional matrices, you're going to use H5 or ZAR to basically support the respective formats. And the respective data that could go in those is anything related to connectivity or other types of relationship information such as distances. With the respective metadata JSON containing information about the files that were used to derive the matrix, the dimension and the axis of the matrices, and the way it is stored in, and much more. Furthermore, we have a node indices file that will be used to describe what the rows and the columns of the matrix specifically refer to, where the indices are coming from, and so on. And importantly, we include this file to allow the description of of relationship matrices that were derived from a subset of regions from a given atlas, or a mixture of different atlases. Last but not least, we also have a look at dimensionality reduction-based networks. This is the structure we are proposing. We have a set of top-level files providing general information about the model and utilized analysis and the outcomes you're getting out of this. For the later, we have the modality-specific files, which will get a general map extension that's going to be pre-pended with the modality of the data at hand. So in this example, we have data from fMRI and EEG, and thus they get the EEG map and bold map extensions respectively. Having a look at the top-level files, we have TSV files containing information which model was applied to which data, and a JSON file containing general information about the model, such as its type, its name, the underlying algorithm, as well as software-specific details in order to enhance fairness while also allowing some sort of flexibility and covering idiosyncrasies between all these different software tools out there. For example, the outcome of an ICA applied to EEG data would look like this. You got the spatial representation here of the derived components, which we would denote via a model key value pair, indicating the model that was applied to the data, and the params components key value pair in combination with the EEG map extension. And the metadata basically pointing to the top level model information, as well as including details of the derived components. The corresponding time courses of these derived components would be in the other file you see here. That is the mixing, param mixing file. Similarly, taking gradients obtained from fMRI as an example, the respective components would again be denoted by the params components key. We have the model key and ID pair again, and the modality map extension, which here would be bold map. And with all of that and more in place, we worked on the last aim of the project, which is to seek and integrate feedback from the diverse community of BIDS users and developers, and ideally beyond that as well. Within that, we promote the adoption by updating existing BIDS validators and utility libraries, and prepare created example data sets. That's good. Closer? Okay. Prepare created example data sets that will be made available on OpenNeuro and BrainLife. And based on this and throughout the entire project, we developed a set of quite diverse resources that we publicly share with everyone to support the BEPS as well as all interested stakeholders. As an example, we created utility software packages for each BEP we're working on. And to give you a brief glimpse into this, we have one that is called BIDS DWI models, which is basically a BIDS app that allows you to run different models and software packages on preprocessed diffusion data and obtain outputs in a extension conform format. We also have BIDS Atlas, which is a small package that allows you to query, access, and utilize commonly publicly available atlases that are out there and used by all of us every single day, I guess, in a BIDS Atlas conform manner. And we also have one called BIDS RealMat or Real Matrices, which allows you to add extension conform metadata to already computed relationship matrices. All of this and much more information about the project, including the information, background, scope, and resources can be found on the project website that you see here. And we also have an OSF page with all data, code, and documentation, which all of you are more than welcome to check out. We also hold open project meetings every 2 weeks on the first and third Tuesday of each month to discuss further problems, development, and examples. And this is also open to everyone interested. And using this infrastructure, we already ran through a lot of the development stages and are currently working on converting the candidate specifications to put them onto GitHub and get feedback. And had our first-person workshop during OHBM again, and currently going towards adding all specifications to BIDS and finish the project manuscripts. And I was told time is over, so I'm going to rush through. If you still want to get involved, there's always time. Just reach out to us via one of the modes of contact we outlined. I'll stop by the poster, number 2224, on Wednesday and Thursday. And with that, I'd like to thank the entire development team that worked on it, the NIH funding this project through an hour 1 of the Brain Initiative, and you for your attention.
Yes, thank you very much, Pierre. I think the PI is here as well. So is there any questions from the audience? Okay, if not, I have a question here. So how do you work with if the data are coming with cultural difference or different races? So how does this connectivity project will handle this difference?
That's a tough one. As standard developments are already tough to begin with, I think the solution to it is the same. Get as many people involved in this as we can from the very beginning and try our best to keep it as broad and diverse as we can. Because if we are missing out crucial aspects of any of these data types or analysis that are supposed to be covered under this, we're not doing a good job. So really that's what we try to do throughout the entirety of the project, reaching out, making sure everyone is felt welcome, everyone knows how to reach us, having all these open meetings and open formats of interaction. So to give everyone basically a seat at the table.
Okay, thank you very much.
Oh. Sorry, one more thing. I was told to remind everyone about the BIDS town hall that's happening on Thursday, 1 p.m. Sorry.
Thank you.